ඉන්ට මංශයා කරන්න. ඕකේ හැමෝට මව ඇහෙන ඇති කියලා හිතනවා. Is my screen visible for everyone?
Yeah, it is. You can see that.
Okay. Uh, to begin with, um, let's understand what logic is and what kind of a relationship logic has with mathematics. So, in our course, in this module, we learn maths, and logic is a we can call a sub subject in the mathematics part. So, before going to that, we have to understand the common features in mathematics and logic. So, logic and maths are in the same bucket. Why do we call like that? Um, like it has this deductive system. What is a deductive system? Deductive system means it's like, everything is abstract. අපි දන්නනේ මැත්ස් කරපු හරිටම දන්නවා ඒගොල්ලෝ ගොඩක් වෙලාට there are a lot of concepts, even like, we just imagine those things. They are not in real world. Those are abstract concepts. So in logic also we talk about such things. It is a deductive system. Logic is a deductive system, same as mathematics, in which these components, these elements, you see now, these things, these are mandatory in any kind of a deductive system. So elementary terms, which can be also called as primitive terms or non-interpretative terms. So I think you can get an idea, like, අපි දන්නා addition එකක් කරනකොට එතකොට අපි දන්නවා symbol එකක් නේ. So there's a symbol, like addition, subtraction. We know these symbols in maths, but has anyone got an idea as to what this is really? But there's just a sign that we say මේක තමා addition එක. This is the addition. We say we have assigned that. So elementary terms. Elementary terms are the terms that do not have meaning. Like they are just there. We identify those things as they are, and there's nothing we can talk about that further. So interpretative terms next. So interpretative terms are the terms that we give interpretations. So those terms get meaning through the way we deal with that. For example, let's take, p, q, r, s. Those are the variables that we use so often. So let's take those things. Sometimes we say we get a sentence like this. um, uh, it's raining. Okay, it's raining. So that is p. We say it is raining. So we assign p as, this is this is what we are referring to. Like that, it is we who are interpreting that, not the construct, not the mathematical construct which is always available there. So then the next element, rules of inference. අපි දැන් අර කලින් මැත්ස් වලදී හැම ගොඩක් දේවල් අලුත් කියන්නේ මේ මෙන්න මේක මෙහෙමයි නියතයක් මේක rule එකක්. This is the rule. We have to adhere to that. Like that, in a system, a deductive system, we have to follow the rules. We have to adhere to those guidelines. Okay, then axioms and theorems, those things you know, and you have heard a lot of about that. And in the previous sections in our mathematics part also we learned those things. So I'm not going to talk about that. Then I think most of you have joined now. So simple sentences and complex sentences. So මම කිව්ව මුලදී logic කියලා කියන්නේ something similar to mathematics and those
Excuse me, Jude.
yes.
Before you begin, can you just scale up the document a little bit so the people
Okay.
watching with your phones can see clearly?
Okay.
Just a little bit. Ah, okay. I
Okay.
think that's okay. Thank you.
Okay. So I think you have an idea as to what mathematics and logic is now, because we have talked about that in a different scope, like taking those two in the same system. So we see how symbols are used in the same manner, how the variables are used. All those things look the same, but there's a difference. In mathematics, like we give always numerical values, but in this subject, logic, we don't use that. We have two values. What is that? True and false. So truth and falsity, those two states we talked about. Okay, then uh, there are so many expressions that we can daily meet in our life. We sometimes talk about things, and sometimes we get confused with some things like we say nonsense, right? So let's have a look at what is really logic is related to um, in relation to this. Okay, wait, give me a second, I'll share it. Okay. uh, okay, now we'll see this. Okay, mathematical logic. Okay, when it comes to this section, we are talking more things related to mathematics, and also which combines logic. So um, now in this propositional logic, and there's the other one, predicate logic, or the we can say propositional calculus, and also the other one, predicate calculus. Those are the two things that we have in our syllabus. Okay, so first of all, we should understand the very basic component in logic. Just like the way we use numbers in this mathematics subject, similar to that, we have to use some variables, propositions, those things. So we are going to have a look at that. So simple sentences and complex sentences is the next topic that I'm going to cover. Simple sentences and complex sentences. So a sentence can be anything that is descriptive, and it can be it is providing something, something new, or maybe like something like catchy, or some idea. It conveys some idea. So a sentence is like that. But a proposition is also like that, but it is somewhat different. What is the difference between a proposition and a sentence? So we are going to have a look at that. A proposition is a statement that is by itself either true or false. So we say a proposition should be a declarative statement. So a statement that is declarative. What is declaration? Declaration means anything like meaningful, anything meaningful. So it provides a meaning, it conveys a meaning, and at the same time it can be falsifiable. Like falsifiable means like it has either true or false value. So we assign that value, and there's a chance of that being false. Always we can make it false, or like that we can argue with that. Now imagine there's a statement like this. Some supernatural things, let's say, um, I will attain supreme nibbana. So in that sentence, what nibbana is not certain. That is not clear. There's no certain idea in that. But if we get a sentence like this, water boils at this temperature, like that, we can say at 100 degrees of Celsius, we can say like that. So it is definite, we can see that, and we can we can say that we can experiment it, and we can say it is false, like that we can say. So those things are two different things. So the first thing that I told you, that can be a sentence, but it would not be a proposition, because uh, it cannot be falsified. Why? We cannot talk about something that is we cannot empirically experiment. So that is the thing. Okay, so it should be uh, either true or false always. Then moving up to the next one, we have here some examples. You'll see, puppies are cuter than kittens, kittens are cuter than puppies. So here there are simple statements. Okay, then we'll look into some more examples. I stay out too late. Then that's what people say. Those things, those are also propositions. But when it comes to sentences, there are some sentences like these, which are not propositions, commands. So here, fly you fools, it's just a command, but it does not convey, at the same time it does not convey something meaningful. So that we call uh, just sentences, not propositions. And here also, questions. Why humans sit like this? That's a question, just a question. There's uh, no true or false value we can assign for that. Okay. And next, here, some nonsense, some gibberish. So that is also, we cannot find whether it is true or false. So that we don't take them as what? Propositions. So, propositional logic is a mathematical system for reasoning about propositions and how they relate to one another. So, in propositional calculus, what we do is we are going to see the relations between those propositions. So, those propositions can be represented by propositional variables. So, in the same manner, like you see how um, 2 is multiplied by 3, and there you see the relation, a relation between the two numbers, two integers, 2 and 3. So you see a relation. In the same manner, we are going to see the kind of relationships, or the kind of relations the variables, propositional variables, have. Okay, so just like the operators in mathematics, in propositional calculus, here there are connectives. So it's like this. Um, each variable has their own meaning, and at the same time, we are going to see how each of these are connected. Okay. Here, this is the rule. We have this um, idea that all propositions or propositional variables should be written in these lowercase letters. But in our A level syllabus in logic, we have to write all those propositional, sentential uh, variables in capital, or maybe uppercase. Okay, now I'm going to change into another part of this. Wait. Um, okay. Okay. Now, you have got an idea as to what any one um, these are uh, really propositions or not. Okay. Um, Here, telephone numbers in the USA have 10 digits. Anybody is there to tell me whether this is a preposition and why is that? For because of what you can say that this is a preposition. Telephone numbers in the USA have 10 digits. Anyone? You can just unmute yourself and talk. Any volunteer? Okay, as it seems nobody is there, I'm going to talk about that. Okay, telephone numbers in the USA have 10 digits.
Yeah.
Okay, Sona.
Hey,
Yeah.
so it's a proposition because the answer is true.
Okay. Like actually, I am not aware of the number of digits in USA telephone numbers, but we can just can go there or we can have like we can understand that and we can experiment that. We can go there and see. So that's correct. Then the moon is made of cheese. Oh, like it seems like the moon is made of cheese. It sounds like it is not natural, but we can check that, right? So that we can take it as a proposition. And the next one, 42 is a perfect square. So, is that true? Anyone? Is that true? No, right? So, even being so, we can take it as a proposition because we can test that. And the next one, every even number greater than 2 can be expressed as the sum of two primes. So every even number greater than 2, again, we don't have like whether check whether it is true or false to just to say that it is a proposition. We can, if it is falsifiable or it can be like experimented and we can evaluate whether it is true or false, then we can take it as a proposition. And the next one, 3 plus 7, that is also like obviously we see that this is false, right? But we take it as a proposition, and you can hear. I'll share this later, but I know that you can't go through everything by tonight. So and this is we have to get ready for the exam as well. So I think this would be beneficial for you later. Um, okay. And the next one, atomic versus molecular statements. සමහරවිට ඔයගොල්ලෝ හිතනවා මේවා තියෙනවද කියලා. මේ ඇත්තටම මේවා තියෙනවා. ඒකයි මම මේ ඒ කැලේ දාලා තියෙන්නේ. Atomic versus molecular statements. Atomic, as the name suggests, atoms and molecules. So those two terms, I think you all you have heard. So atomic is simple sentence or simple statement that cannot be further divided into statements. So there's just one statement and we cannot further divide it into another statements. And also it has meaning even when taken it alone. Okay. So you don't have to like have another sentence, another statement to have meaning in that. For example, let's say um, um, for example, it is the same example that we got. It is raining. So it is raining. There's nothing more to add to that. Okay. So then the molecular, we can say molecular. අපි කියන සංයුක්ත කියලා molecular. So more than one statements. So there are more than one statements, and these we refer to molecular. For example, we can say um, uh, mother and father went to the party. So both people have gone, right? So there you see mother went, okay? Mother went to the party and father went to the party. We combine those two. We combine those two and we say what? Here, I may write it down. Um, Mother went to the party. The same father went to the party. So the same thing you can මේ දෙක කම්බයින් කරන එක තමා කම්බයින් වෙලා උනාට පස්සේ අපි කියනවා this is a molecular statement. So instead of writing this separately, what do we do? Here, mother and father, we add this and this connective to that. So we call it molecular statement. Okay. Then the next one, we are going to analyze what a logical expression should have. So the components of a logical expression. The first thing is sentential variables. What do we call sentential variables? Then ඔයගොල්ලන්ට මතක ඇති at the first time you saw how we used PQRS up to Z to show a statement. So or an expression or a atomic statement. Okay, the atomic statements are the ones that we talk about here. Like we don't talk about molecular statements as sentential variables because every molecular statement can be divided into further divided into atomic expression, so that we talk about those atomic stuff. So it is sentential variable, we refer it as that here. So the simple sentences are symbolized using P, Q, R, S, T, U up to Z. And if we stop it by Z, because then we have again A, B, C. Likewise, we do have those name variables. Those name variables are later be used in predicate calculus, but I don't think that those things would be there in the paper because the lecturer didn't teach us that part, the name variables. So here we are talking about this calculus because this has been first discussed by Aristotle. So Aristotle has developed this idea, this kind of calculus first, and then it has been developed, evolved, and then it has come to the predicate calculus. So this is the very basis of everything. So um, so before that, Aristotle founded this syllogism and those theories, and then with the set theory came into the discussion. uh, this idea, this first of all, let's talk about this. There was this idea that everything can be uh, you know um, can be argued, and then finally we have to come into conclusion like that. Those discussions were there. Then after that, Aristotle has formed this syllogism theory, and then after that, George Boole and people like Leibniz, they came into this symbolism concept. So they wanted a language like now you and now all of us talking at least two languages, English, Tamil, or Sinhala. So those three languages, sometimes it is difficult to understand when someone is foreign to your language. That person would be in a difficult situation to understand what you are saying. So but the structure of whatever you are going to say is the same. Like you are going to talk about something, and it is the exact same thing that the other person wants, and he or she understands, but the way, the language, because the language barrier is there, you cannot understand. So that is there. And ඒක අහක් කරන්න they needed what? A language, a logical expression, a logical language. So that is why they started working on developing a language like this, a logical expression, so that everyone can understand. So the purpose of us learning this is to understand, අපි දැන් මේක ඉගෙන ගත්ත අලුතෙන් implication එක, by conditional, those things, they support us to understand how to make logic circuits, all of that. Logic circuits වලදී අපි mainly there are three operators that we use, but here there are some other parts, which are closer to our natural languages. We always talk about those conditional statements we have, but in the regular forms like and operator and or operator and not, we have limited space for that. So this helps us to first convert those natural language statements into logical form, and then we can make equivalent statements in order to make those logic circuits. So that is the real purpose of having this. Okay. And with keeping that in your mind, let's move on to the next component, logical expression. Here people asked to you up to Z, and make sure to keep them in lower case, because that is what they are in the slides. Okay, then this if you are referring to something like this, if you are telling that it is raining, and you are going to give a symbolism to that statement, you have to have a scheme of abbreviation. ඔයා දැන් මොකක් හරි එකක් ප්‍රකාශනයක් ලියනවා නම් ඒ ප්‍රකාශනයේ අනිවාර්යෙන් තියෙන්න ඕනේ සංක්ෂේපන රටාවක්, scheme of abbreviation, which means ඔයා මෙන්න මේකෙන් කියන්නේ මෙන්න මේකයි කියලා, you have to like it's like you are giving the keywords, like in the same manner you have to give this thing, scheme of abbreviations. This thing you have to provide always. Okay, without this it's not gonna work, because the lecturer or the person who is marking does not understand the way you have like you have taken, like you have your own variables, then you have to mention that this represents this. Okay, uh, it is based on this that they mark your answer. Then logical constants and their different sentence patterns and symbols, that is the next thing that we are going to uh, understand. The first thing that we talked about was the variables, and next we are going to talk about the constants. Okay, then okay um, the first thing, negation. Negation is used to indicate negativity. Always, it provides a negative idea. Now think, uh, wind blows. The negative statement is wind does not blow. Now, if we take a sentence like this, um, this cloth is white, or maybe no, the uniform is white. And what should be the opposite of that? Anybody? Any volunteer? The uniform is white. What is the opposite, or maybe the negation of it? Is it the uniform is black? Is that the negation? No, right? So obviously, negation should be that is correct. Uniform is not white. It should be not white. So දැන් ගොඩක් අර කළුයි ඒකේ අනිත් පැත්ත සුදුයි කියලා එහෙම ගන්න that is not the proper way. Like it is something in the middle. You know, if something is white, the negation is not white. If something is black, the negation should be not black. So keep that in your mind, and not get don't get confused with when you're translating terms. This is a very simple thing, but sometimes when it comes to some other um, other examples, we get like confused that this is the whether this is the really negation of this statement. Then conjunction, this is where you find your philo and gate. Okay, so and we call it an and, but here we always refer to it as the conjunction. So conjunction does not mean that the two things before the conjunction symbol and the after the conjunction symbol should be should happen at exact time, like at the same time. It means it rather it means like those two factors inseparably connected. Like if like imagine, mm, um, if it rains, uh, no, if it like all the time, like every day, now imagine, like let's say අපි හැමදාම වහින දවස් වලට you get flu. Okay, you get flu. So there's a connection between those two, or the way you get flu and the raining. Those two things, those two factors have a shared quality. That means those things happen within the same time and same space. Same, so spatio temporally, those two are connected. So therefore we can say, uh, we can use conjunction. So here, when wind blows, trees fall down. Okay, when wind blows, trees fall down. So there can we can use we can make a lot of sentences. We can have examples like that. So here we have, I think you got the idea as to how to represent it using the symbols. Okay, and always keep in your mind how you to use brackets all the time, because you sometimes uh, feel it is like a lot of ambiguity is there if you don't use um, brackets properly. So that's it. And then the new philo, implication. The sentences which indicate consequent as a necessary result of antecedent are okay. Then you don't have an idea as to what these terms are, these terminology. Okay, implication. Implication means, you know what implies mean, right? Which means uh, there's this first variable or something like that, and there's the other one which becomes the output, or maybe the because of the first thing happens, the second thing happens. Like it is based on the first thing that the second thing happens. So හිතන්න අපි අපි යම් කිසි දෙයක consequence එකක් කියලා කියන්නේ මොකක්ද? ඒකේ බලපෑමක්. Yeah, in the same manner, like what I said was, um, we call a consequence what is the consequence? Consequence is a result, right? So the first, before that, we should have something, a cause, right? That cause or the reason we call here antecedent. Why? Antecedent, which means purvanga. And the next thing, the consequent, it is the aparanga. So those two things, these these are the two variables in a implication. So anywhere you can find these kind of conditional statements. If he goes up, then he comes down. Udapan, like that. Okay, here scheme of abbreviations. Here we have given the scheme like he goes up, he comes down. Here I have named it, labeled it just for you to understand. Antecedent. Not it is not needed to write down these things. Okay. Then symbolization is there. Then the next one, weak disjunction. What is weak disjunction? Is weak disjunction is the normal disjunction that we use, like the or gate. Okay, or gate. So these statements, they indicate at least one alternative. If at least one alternative is true, and then what happens? The output is true. So it is similar to the or gate. I think everyone knows that, so that I'm not going to talk about that that much. So then here the scheme of abbreviation is given. Okay, and next, strong disjunction. Okay, here the strong disjunction refers to the fact that out of the alternatives, one and only one is true. If only one and only one is true, then the output is true. All the other uh, um, chances are false, like the value is false. Here it should be changed. I have changed. I think I have taken the wrong document. That is why the editing part was not there. Here it should be. Wait. Okay. While it is there, I think it's better to switch to the other part because we are running out of time. Okay, here I think this would give you a clear picture about this. Logical not. So not P. This is the way that you have to like um, represent it. So logical negation. P and Q. So that is the conjunction and disjunction. And truth table. So the truth table shows what? The truth value of a propositional logic formula as a function of its inputs. So inputs are there, and we have to like derive the output using those inputs. Okay. Um, okay. Here um, wait, the next one. Okay, this is the most important part. We call this implication connective a material conditional operator. This is the technical name, material conditional operator. So when you are drawing the truth table for this, you have to consider this important point. Okay. here the way it has been like could you please give me a second? I think it is quite noisy here. Give me a second. Okay. Uh, okay, guys. Here you have this to table, but you know the values that are written here is not in the way that we have usually written down in logic. Like it should start from T T F F. Here it should be T T F F, but we have not used that. The reason is because most of the time you are working with this logic gates so that you can understand this easily if I have written down this like this. Anyways, what you have to get is this. Uh, the idea is this 0011. I think you are familiar with that. So 0101, and the output should be like this TF when it is true and false only. If the antecedent is true and then consequent is false, if that happens here, this is false. Okay, so if antecedent is true and what did I call this, consequent is false, this is false. How that can happen? Okay, it is because this, you know, if we අපි හිතමු, let's take an example. It is if it is raining, the ground gets wet. Okay, true and true, and the output is also true. And at the same time, if we say it is not raining, this is the one. Okay, it is not raining, and what happens? It is not raining, and here the ground gets wet. So even though කියන වැස්ස නැති වුණාට පොළොව මේ තෙත් වෙලා තියෙන්න පුළුවන් maybe මොකක් හරි කියන්නේ වතුර මලකින් වෙන්න පුළුවන්, මොකක් හරි ඒ වගේ දෙයකින් පොළොව තෙත් වෙලා තියෙන්න පුළුවන්. It can happen. So it is true. If that it is possible, we say it is true. And here this one, the first appear here, if it is not raining, the ground does not get wet. So that is also possible, right? That's it can happen. If this is not going to happen, this is not going to happen. So then it is true. So we have an example for that, like that. And then if it is raining, ground does not get wet. So the output should be false. Why? Because we see the reason is there. If the reason is there and the consequence is false, even though the reason is there to happen, if it is not happening, we say it is false. It is not going to like වෙන්න විදිහක් නැහැ. So that is why we mark it like that. Okay, so always keep it in your mind that TFF. Okay, if you are making a short note, it is better you mention that TFF. And the next newcomer is biconditional operator. So I think you all are familiar with the other ones. So I think it's important to highlight these parts. So biconditional operator is used to represent a two-directional implication. Hari. we know that there's this symbol implication. Okay, earlier one implication, and the other way around, like we can say this p, from p to q, it is we talked about. Okay, also it can happen like this, like if we put the arrow in this way, like from here to here. Okay, from here to here, from q to p. What do we call that? That is we call this conditional. And if we change the direction of the arrow, we call that converse. So converse of that, that is a converse of the conditional statement. So here the important thing is, when you are writing down the statement in the English language, it is important to note that the first thing, if we say like this, මෙතනදී අපි got the thing, if it is raining, the ground is getting wet. And if we are going to say like this, um, the ground gets wet, uh, like we are going to say the same sentence. I think it is better to write it down somewhere. Wait. Okay. um, Here I think under implication, okay, let's take this example. If he goes up, then he comes down. So if we say, if he goes down, sorry, goes up, uh, I think everyone can see this screen. If he goes, no, let's see, he goes down only if he goes up. Okay, he goes down only if he goes up. Here if, okay, here only if. Okay, so if he goes up, then he comes down. He goes down only if he goes up. Only if means you're taking this, these, the highlighted part. Okay, only if he goes up, which means you're making it more powerful. Okay, just after the only if, the term, whatever appears after that becomes more powerful. Only if he goes up. Okay, then what you have to do is, here this becomes the reason. Only if he goes up. I earlier told you that antecedent is powerful because it is a reason. Okay, here also the cause, the reason is him going up. Okay, only if he goes up, he goes down. So we can change this a little bit, not in the paper, like you can just in your own, like you can do that, uh, it as you wish, like only if he goes up, then he goes down. Okay, that is the theory of that. Okay, now let's imagine another sentence. So you got the idea here, right? So when you're understanding that kind of a sentence, you have to work on that a little bit. Okay. If you get a sentence like that, let's write down another sentence. If mother is cooking, okay, only if mother is cooking, we can change. We can eat only if mother is cooking. Okay, then you can write down this scheme of what? Scheme of abbreviations. Okay, you just write down it like this. P is such that it is what, um, we can take like, in logic, in level logic, we have to take like it in the order, like how it happens, uh, the order of happening, like the way how it happens, we have to take that order, not the way the sentences are arranged. Okay, the way the process is being done is the order. So here there's no such order. We can do it the way we want. The most important thing is whether we have given the scheme of abbreviation properly. So we can sorry, we can eat. Okay, wait, here is this eat. So are you all sleeping? Just give me a brief comment if you make it change, or maybe like if you don't want a, okay. Any questions? I mean, do you have a question? Okay. So I think it's clear for you all. And here we can eat only if mother is cooking, which means if mother is cooking, we can eat. And only if stresses the fact that this happens, only this happens, only if mother cooks. Okay. So, the other thing, when you're writing down the scheme of abbreviation, you don't have to consider about the time frame. Like if it like එතන තියෙන්නේ, mother is cooking. So it does not mean that you always have to write it down as mother is cooking. You can just simply mother cooks. Okay, you can just write it the way it is possible. Okay, this is also possible. කාල භේදයක් නැහැ. The other thing, what? Yes, then here, why I have taken mother is cooking at first. Um, okay, we can take it as for the given order. So we can eat here what? Mother cooks. Okay, then how we are going to write it down? Let's symbolization symbolization should be, we can eat, mother cooks. Those are the two things. Okay, so then we can eat only if mother is cooking. So mother is cooking or mother cooks comes first. Okay, then actually this is not my laptop, so that I don't know how to get this. Wait. Um, Normally, okay, it is there. Here, this one. Okay, this. You see that? Okay, you got that. So that is, we call it the converse. Okay, converse. Converse means, okay, before going to the next part, I'd like to make you go through these things. Now imagine, now here you have, I think everyone got the idea here. Okay. Uh, Now this is a different um, different um, part. Okay, don't make it confused with the one that we did. This is P implies Q. We take this statement and we take the converse of it. What is the converse? Converse is, oh shit, what? Wait. Oh my, I have to mind my tongue. Q come P. So P implies Q, and the converse of that particular statement is this. This is what we call uh, converse. Where is this? Okay, converse. This is the converse. Okay. Then, if we get the inverse, what is the inverse of this? Okay. Anybody here to tell me the inverse of this? Inverse. Quick, quick, quick. Inverse. Okay, as it takes time, I'm going to tell you. Okay, it should be, wait, this and um, this one, and oh wait, what is this? Is this the inverse? No, like here, to make it the inverse, we have to just add negation to the two parts. Okay. Um, wait. Um, Give me a second. Okay. Here, where we put. Okay. This is the P implies Q is the statement. Okay, we took. So converse is this. Q implies P. And which means converse means this happens the other way around. Like the same statement. This statement is equal to P and this one. Oh, this. Okay. This is the same. Don't get confused with this uppercase and lowercase. I'm now imagine I'm using only the lowercase. Okay. This anyway. Okay. The same. Okay. To get the inverse, what we are going to do? We just write it down in the same manner, same way, but we have to add negations for both consequent and antecedent. And the other one is this. Oh, this. Oh, okay. Now, I think you are taking notes of these things. This is not. Yeah, this is inverse. And the next thing, there's the other thing, like what I did earlier. What is that? This one. And okay, you got this. Okay, P implies Q, and this is, we call this contra positive. Contra positive. Okay, keep this in your mind. This would be helpful for you. Okay, and after that, so we talked a lot about implication, and um, then we are moving on to biconditional operator, or like this. So biconditional, uh, I think, uh, do we have that? No, okay. Um, Wait. Okay, biconditional. Biconditional, which means um, implication happens both in both ways, like the way we did here. Uh, we take P implies Q and Q implies P. We take those two, uh, these two. Okay, we take these two and then write one thing. That is what we call P biconditional Q. So it's like this and this. Those two, we like we represent this in one symbol. That is what we are going to do. Okay, so I think that is clear. That is a very basic thing, and I'm explaining that. Okay. Uh, okay, then you have a clear picture about that. It's difficult to find this. Okay, then um, okay, you got the idea there, and here in this, you see how we derive the output of this. So when the two values of the two components here, P and Q, are equal, the result should be, the output should be true, which means හිතන්න වැස්ස වහිනවා, වැස්ස වැස්සොත් හා වැස්සොත් පමණක් ගඟ පිරේ. වැස්ස වැස්සොත් වැස්සොත් පමණක් ගඟ පිරේ. Which means if only and if it rains, the river like maybe is full. So there, the river to become full, uh, raining was needed. Okay, in the same manner, so it goes both way, like if this happens and only if this happens. What we say? If this happens and only if this happens, this is possible. Okay, and uh, then if and only if, so that is there. That is how we combine implication and the converse of the implication. So here, if I further elaborate on that, I think I'm taking a lot of time for that, but I think it would be useful for you to get the idea clearly and then move on. Okay, so f here, it should be true, and I told you that when the two values are equal, it should be true. The output should be true in this line. Okay. And here, uh, if the two values are two different, like false true or true false, it is false. That's it. And if we take an example and look at this, uh, um, like let's say, um, if I go to the university and on if and only if I go to the university, I can study. Okay, so which means if you go to study, you study, and also you if you study, which means you are going to the university. Okay, that is this true. Wait, this one, this line. Okay, this one. So it is true. And then uh, if I go to the university, sorry, if and only if I go to the university, I do not study. That is false, right? You are going to the university and also you are going to study. So in the same manner here also, if I'm if I'm going to the university, I would study. But here, if I'm not going to going to the university, uh, if and only if I'm not going to the university, I study. That is false. If you are going to the university, which means you're going there to study. So if you are not going to study, if I'm not going to study, uh, so if I'm not going to the university, I would not study. So that is also true. Uh, okay. So there's this as well, like but we did not use that much. Connectives, there's this constant true and false symbol. I don't think that we have to use that much, but note that down also. Then the operator precedence is important. Give me a second. So I have covered what a deductive system is and what logic and maths are, and then sentences, and then propositions, and what are they and what are not propositions we discussed, and the atomic versus molecular statements, and what we have missed was compound propositions. So compound propositions I'll discuss in a second. Um, and we discussed in propositional calculus what constants and connectives are. And these connectives are also we refer as constants, because these are not going to change in the system, because අපි එකතු කිරීම ගත්තතින් ඒක change වෙන්නේ නැහැ. In the same manner, these symbols, conjunction, disjunction, those things are not going to change in the system. Okay, then the precedence of operators. This is important because we have to create everything unambiguous. Like we have to make everything clear. Now here here it is a sequence of symbols. Okay, this is a statement though, but it's not clear because we have not used brackets properly, and also we have not understood the uh, clarity in the statement, like it is not visible proper clarity of it. Okay, here the first thing that we do now, I think everyone has this logic tutor, not tutor, like sec it was the second one. Okay, so the second tude, I think you found there the precedence part, operator precedence. It should be wait, I'll I'll share it for you, but I can't find it here. That's a problem. Okay, now I'll type it for you. Wait. Okay, now, uh, now here. Okay. Mm, let's say uh, this statement. Okay. Uh, okay. Now, uh, I think this is clear for you all. Anyone to tell me whether tell me what this really means? Like now, I'm going to give you um, the um, list of there's a scheme of abbreviation of this. P says what? Ma cooks. No. Um, play cricket. Okay. Uh, oh, I study maths. Okay, these two. Okay, now anyone here, any volunteer to tell me, uh, like convert this into English, this statement? Anyone? Just unmute yourself and tell me. Anyone?
If I don't play cricket, I will study maths.
Okay. If I don't play cricket, I study maths. That's the correct answer. Yeah. Uh, okay. Yeah, I'm seeing. Yes. Okay. That's correct. And here, sometimes, let's say mm, you understood that. Okay. Now, you see, um, now if we take this, um, okay, guys, do you guys need a break? No, eh? We have just started it, right? This is the time. It's 10:18.
Yeah, it was just 1 hour. Let's go some more, no?
Yeah. Okay. Here, actually, I'm a bit like in a difficult situation. Like I don't have a whiteboard, so that it takes time for me to type everything and show you. Yeah.
Yeah, you can take a break if you want a break. Like,
No, I what I
mm.
wanted to I want to depict these things, but it takes time. Okay. Meanwhile, if you guys have any questions, you can ask me, but it should be something related to the topics that we are currently like working on here, or else
Dude, I
if you
think, yeah, it's
yes,
almost 10:20 now. I
yeah,
think we should go a bit fast, no?
okay,
Like we
okay,
have some.
yes,
I
Let-
I uh, I don't know what others think.
yeah.
You guys can message him if this is fast or you want to go faster, or if this is slow. Yeah.
Yes. Okay, I have the. Uh, so precedence of logical operators here. Um, if it is not P conjunction Q, then the here how to have this. Hmm. Yes, clearly, like we have to give the precedence to uh, not like what do we call negation, and then uh, we have talked about uh, those things and what I missed. Okay, shall we do some examples? What is name? Okay. Up to now, do you have any problems like understanding the stuff that I've like explained? Do you guys have any problem? Okay. Then uh, here. Okay, wait a second. I'll join. Just give me 3 minutes. I have some issues with this laptop. Like it is difficult for me to handle. I'll join within 2 minutes.
ජූඩ් ඉන්නවද ඌ?
මේ ඉන්නවා පොඩ්ඩක් ඉන්න.
හරි.
ඔයගොල්ලෝ මං කියන එක රිපීටඩ් නෑ නේද?
නෑ නෑ.
ඕකේ. එහෙම නැත්නම් okay. Okay. Here, now, I think everyone can hear me. Under this strong disjunction, I think you can see here another new symbol, this one. This is strong disjunction, but we can use, I think, the logic gate operator as well, XOR gate as well. This is exactly what XOR gate is. True, it is like you know what kind of values in the output you will see. I think you know that, and thinking so I'm going to explain this. So here she will register at one and only one of universities of Peradenic, Kalaniya or Ruhuna. So this statement, if we take this statement, we can break it into three propositions. What are they? She will register at University of Peradeniya. She will register at University of Kalaniya. She will register at University of Ruhuna. So those three, we can like join all three with two what? With two strong disjunctions. Okay. So with two strong disjunctions, we can connect them, and so it is the easiest method. But if we are to have equivalent formulas for that, we can take this. But the first one, what is that? P or Q, and not P and Q. Here, what we say is this: P or Q happens at the same time. This conjunction refers to at the same time. So those things happen at the same time, which means those are happening maybe in the same timeline or maybe in the same space. It they are connected. Okay, these are connected. So these two happen, and at the same time, these two happening in at the same time, that is false, which means here if we take like this in the above example, captain bat first, vice captain bat first. So out of captain and the vice captain, one and only one will bat first. So which means one of these two people bats, which can be expressed as either vice captain or the captain bats first, but those two cannot bat first at the same time, one of them. So that is why we use this first formula. Likewise, there are other formulas. These formulas also we can derive from by making another equivalences. So that is it. And um, here, biconditional, actually there's nothing much about that here. And the other thing, what you have you in your short note is this. Biconditional equals to uh, not not XOR, which means the negation of XOR gate. Okay, so XOR gate is there, and the negation of it equals to biconditional. So anybody here to tell me what is the opposition of biconditional, which means negation of biconditional? Now I said here we learned about what XOR gate. Okay, XOR gate is the similar uh, the similar one to this disjunction, which disjunction, strong disjunction. It is similar to that. So I told you, if strong disjunction and it is if we take the negation of strong disjunction, it is similar to biconditional. So what would be the uh, opposition of or sorry negation of the biconditional? If A's negation is B, then B's negation should be A, right? I mean, if those two are like if negation of A equals to B, what should be the other way around? It should be negation of B should be equals to A, right? So in the same manner, biconditional, if we take the biconditional, it equals to let's say I think you need it to be uh, right. Yes, this is not new. Oh, oh, okay. Okay, I'll write it down here. Okay, so biconditional equals to negation of what? Strong disjunction. And what else? Biconditional's negation equals to strong disjunction. So what you have to do is you have to just write down the truth table and see whether the outputs are the same. Okay, let's take a simple example like this. P I just write down the because I can't find this this thing. I just type it here like this. Okay, uh, P and Q should be equals to not P. Um, what is the symbol? This one. And um, Q should be within brackets, right? Otherwise, there's an ambiguity. Why do I say so? If there's no brackets here, it takes because of the precedence here. It if we don't have if we don't put brackets here, it gives the idea that it is not P. It is not the not P. The negation of the whole statement. Okay, so you have to be careful in having brackets. Okay, and that is it. Okay, and uh, let's have a glance at the tudes that we have got, so that we can keep in track with that. So we have covered mathematical statements, propositions, atomic, those things, then logical negation. Then we talked about the truth tables of those connectives, and then we were talking about the inclusive and exclusive. Oh, so exclusive is XO gate, and the other one, the weak disjunction, we call it what? Inclusive O. So here there are examples in English language, so that you can please go through the lecture note first, okay? Uh, then I'm not providing you language expressions here, like, because those are, I think you can manage. Then the first part is then compound propositions. So compound propositions are the propositions where propositions are connected using like other connectives. So when like, let's take not Q, that's also a part of a compound proposition, because it does not, it is not the atomic proposition. So that is a compound proposition. And then we are going to apply those things. So those theoretical parts we are going to apply now. So let's have a look at how to um, check um, those tautology and those stuff. Now we are moving on to those things, okay? And I think you can easily draw the logic circuit, because you have the concept in uni, so that I don't go to like explain on that. And here tautologies and tautologies, contradictions, and there's something else. What do we call that? Wait, where I'm going to type it. Okay, here. Uh, Tautology, then contradiction, and that's the other thing. Like this. Wait. Up to now, if you have any questions, or if anything is not clear, just tell me. um, I think everyone can get the ideas that I'm referring to. Okay, contingency. Okay, okay. Here we are going to talk about just one. We are taking just one expression, and we are going to check whether it is a tautology, contradiction, or contingency. Okay, what are these things? Tautology. So tautology refers to whether we are repeating the same thing in the same expression. Like if that expression is like, අපි සිංහලෙන් කියනවා නම් මේක කියන්නේ පුනරවාචකයක් කියලා. හරිද? පුනරවාචකයක් කියන්නේ පුනර්වාචකයක් කියන්නේ පුන පුනා කියනවා. නැවත නැවත කියනවා කියන අදහස. එතකොට මේ ඒක පුන පුනා කීමක්ද මේකෙන් කියන්නේ කියන එක තමයි අපි tautology එකේදී බලන්නේ. එතකොට අපිට හිතන්න, for example, let's take this statement. Okay, let's take this. Okay, now let's make it. Okay, and no, අපිට මේ හැම එකෙම තුනෙම examples ගන්න ඕන නිසා මම let's make it like this. Okay. Let's see whether this is a tautology or contradiction or contingency. Okay. Mm, we are going to write down the input values here. Okay. T, T, F, F. And here, oh, sorry. Here there is only one variable. So it should be true and false here. And here it should be true and false. Okay. Anybody disagreeing? Anyone who is disagreeing to what I say? Okay, it's fine, right? So that's it. And then uh, you have learned that when okay, anyone to give me the output of this? Like what happens? I need a response. Hello. Hello. කට්ටිය නිදිද? Okay. So here what has happened, we know only when only when the two two inputs are false, like if at least one variable like has the value true, it becomes true. So here uh, at this point it is true and false. So it is not going to be what? It is not going to be a tautology. So what is a tautology? If you get get an output where all the output, like the list, is true, like you get T's. Okay, all the T's, all the outputs are T's. We call it a tautology. Okay, you got that right, guys? You got that? I hope you got that. So this is not a tautology, but we call this contingency. Why do we call it a contingency? Because it contains both true and false values. Okay. Then uh, um, what do we take then? Let's take this. Okay. Anyone to check this and tell me whether this is a tautology, a contradiction, or contingency? I think contingency is something new for you, but I think you know tautology and contradiction. So tautology and contradiction, if you found the answer, just tell me now. Just only one variable here, which means, I know that you all know how to get the number of like options. Those things, I think you know. Okay, I got an answer that it is a contradiction. Okay, we'll see any other answer. So here it should be what? and here it should be what? But it should be. Any other answer? It should be here. P gets the input like T, F, and not P, F, and T. So T, F, it should be what? Anyone to tell me that answer? Guys, yeah, are you all asleep? Okay, should be T. Okay, okay. Then here also it is should be it should be T. Then what do we call this? We call any compound proposition that is always false is a contradiction. But here, Viman, we have made a tautology. Okay, we have got tautology. Okay, then let's try this one.
ජූඩ් ඔයාටයක් ඔක ටර්ම්ස් තුන මේ පැහැදිලි කරන්න මොකද මේ ටෝටලොජී කොන්ට්‍රඩික්ෂන් කන්ටිජන්සි
Okay,
යන්න කියලා
okay. මෙහෙම okay. ඉස්සලම මම කියන්නම් ටෝඩ්ලොජීස් මේ විදිහට අපි මේ පාවිච්චි කරන්න මේක කියන්න හේතුව සමහර වෙලාවට we need like in the same expression if that is like if it is repeating, like it is repetitive, we can find like it is now හිතන්න ලොකු දිග expression එකක් තියෙනවා කියලා. If that is expression is a tautology, sometimes there might be chances of understanding that easily in a different way. So to understand a mathematical argument, sometimes like we can replace those arguments in big mathematical let's say හිතන්න අපිට ලොකු calculations එක calculations හරි මොනවා හරි එහෙම දෙයක් කර පාවිච්චි කරනවා කියලා හිතන්නකෝ මේ මොකක් හරි expression එක. ඒ expression එකට වෙනුවට අපිට substitute කරන්න පුළුවන්. අපි දැනන් හිටියොත් මේ if this is a tautology, so අපිට ඒක සමහරකට මේක repeat වෙන තැනකට අපිට මේ ඒක පාවිච්චි කරලා අපිට යන මේ ඉඩ අඩු කරගන්න පුළුවන්. ඒක දැන් මෙහෙම කිව්වට එකපාරට ඒක තේරෙන්නේ නැහැ. කොහොමද මට තේරෙන්නෙත් නැහැ ඒක කොහොමද ප්‍රැක්ටිකලි පාවිච්චි වෙන්නේ කියලා. but එහෙම තමයි ඒක පාවිච්චි වෙන්නේ. කියන්නේ ඒකෙන් අපිට පුළුවන් මේ replace කරන්න අවශ්‍ය තැන් වලට.
ඒක අවුට්පුට් එක එකම නම් ඒක ටෝටලොජි වගේද
output එක කියලා කියන්නේ here we have to consider just only one expression. හරිද? ඒ expression එක එන output එක සම්පූර්ණයෙන්ම t පේලියක් නම් if the output is a full line of t's, we call it a tautology. And if it is a line of f's, we call it a contradiction. Okay, and the whole line, if the whole line is a tf, a combination of both truth and false, we call it a contingency. Okay, is that clear?
yes dude thank you that's what I'm talking about
Okay, to get an idea as to what okay, let's do this as well. It should be false and yes, this should be true, and false, and here all the uh, you know there's no t and t to get the output t, so everything is false and false. මේක කරනකොට තමයි ඔයගලන්ට ඒතකොට මතක හිටිනා මේකේ variables වලින් output එක එනකොට ඔයාලා එතකොට අර ඔයගොල්ලෝ මේ මොනවද gates වල කරන ටිකම තමයි ඉතින් there's nothing much uh, to explain the same thing, but there are different terminologies here, and there are some new theoretical parts here like these. So here we have got a line of f's, which means this is a contradiction. Okay, and then we are moving on to the next parts left. What are the next parts left? Okay, then we are going to build logical equivalences. So oh wait, here we have another part. What is this? Okay, here this is not really tautology and contradiction. This should be okay, but let's consider it because in the lecture note it is mentioned that it is tautology. If there are two statements like this, okay, we have to go to quantifiers, those parts as well. So I think better not wasting time on that part. Like this මම ඔයාලට in brief මම ඒ ටික කියන්නම්. හරිද? එහෙම අවුලක් නෑ නේද? මොකද අර quantifiers ටික ගැනත් පැහැදිලි කරන්න ඕනේ.
So අවුලක් නෑ. ඉක්මනට කියාගෙන යන්න.
ඔබ පොඩි මේකට අවශ්‍ය කරන පොඩි නෝට් එකක් දාගන්න මතක තියාගන්න ඕන දේවල් වලට. මෙතනදී P implies Q කියන අපි හිතමුකෝ දැන් මම කියද්දි ඔයගොල්ලන්ට ඔලුවට යනවා ඇති කියලා හිතනවා. P implies Q, and there's another expression not P disjunction Q. Okay, so those two expressions, we combine those two statements by using a biconditional to check whether these are equivalent. Okay, so to check whether these are equivalent. So here the thing that we have done earlier, it was tautology, contradiction, and then what else? Those three parts we did, and here what we are doing here also, according to the lecture note, it is we are finding the whether these two are tautology or contradiction. So let's keep that as it is. So I'm not going to change or tell you anything more about like what is happening here. I'm just getting adhered to whatever the lecture note tells us. So tautology and contradiction. So here, why do we use a biconditional? Anyone to tell me why? What is the purpose? Sinali, are you there? Oh, okay. Now, just tell me, why do we use biconditional to combine those two expressions? What is the purpose of doing that? No idea. Okay, I'm going to tell you. So, අර කලින් එක අපි මම කියවනේ පුනරවාචකය කියලා වචනයක්. That which means the say repeating the same thing. So here we are going to find out whether the first statement is repeated by the second statement and vice versa. Okay, so the first statement is repeated by the second statement and the second statement is repeated by the first statement. So we are going to check whether these two are a tautology. So not just one expression is a tautology, it can be two statements together. So we are combining those two statements in order to find whether these two are a tautology when we get them together. Okay, so I think page number 47 in your tute, you can see that. Please make sure you have that with you because I'm going through that now so that it would help you. I'm really sorry that I couldn't find a whiteboard. It was a mistake, like, I don't have that, but I with a limited time I couldn't find any other resource. That is why I use these things, but I know that it is difficult to explain without a whiteboard. Okay. Anyways, not considering those loopholes, let's move on to how to find a contradiction. So the same thing that we do here, like we are going to make the truth table for those two and then then check whether the final output is a line of a list of f's false. Okay, if all false, then we call it a contradiction, and if not, if it is a mixture of both, it is going to be contingency. Okay, and if all are true, then it is a tautology. That is, I think, clear. And logical equivalences. So equivalences, as the very name suggests, it should be logically equivalent, which means just by looking at it sounds like two unfamiliar two things, but they are logically providing the same idea, the same concept, maybe it's the same idea. So it's conveying the same idea. So we are going to find out how we can compose these equivalences using the knowledge that we have gained. Okay, here after no yes equivalences වල එතන තියෙනවා compound propositions with the same truth values in all possible cases are called logically equivalent. So to be logically equivalent, all the output values should be like go hand in hand, like they should be like if we take the input like input line and the output line, uh, like if one gets the same output in the same like කියන්නේ අපි හිතන්නකෝ input එකේ තියෙනවා නම් true එකක් true වෙද්දී අනික false වෙද්දී the output is true. So ඒ විදිහටම ඊළඟ එකෙත් ඒ combination එක මේ විදිහටම තියෙනවා නම් ඒ විදිහට ඒ line එකම truth table එක මේ විදිහට ගානට line වෙනවා නම් then we call those equivalences. I make it an example. Wait, I better share that. Wait, give me a second. Okay. Guys, you got something right? Like, is it totally useless to like? Do you feel like I'm talking nonsense?
No, no, it's all right. It's all right, but it's almost 11. No, it's 11 p.m. now.
Yeah.
So How much more we have to cover, Jude?
Um, like, would you mind
Like,
uh, give me 30 minutes more? Like, if I like,
yeah, it's all right. It's all right. But the thing is that we have to cover, like, uh, how much more we have to cover. Like,
we have to do those quantifiers, and that is the thing. And then we have to practice some. We have to do some exercises as well. That's why I thought it would take
yeah,
that time.
yeah.
But
It's better if you can manage within 30 minutes.
yeah, okay. Um,
Okay.
ජූඩ් සිස්ටම් ස්පෙසිෆිකේෂන් කන්සිස්ටන්සි ගැනත් කරන්න පුළුවන්ගවාට
okay. Let's go through that as well.
නැකිබ
Okay. So is this? What is this? Oh shit! This is accounting part. Right? Okay. Here, we were in this part. Okay. Logical equivalences. So what I was about to tell you was the trick that you should have before going to the exam. Um, when you're going to find out equivalences, there are some tips. Okay. Mm, here these are the laws. Laws. I'm not going to explain it here. Okay. Logical equivalences involving conditional statements. Um, Here, P, the first one in the table 7, P implies Q. P implies Q. And the equivalence is not P or Q, which means like this. How to convert it? Now, what you have to do is you have to write down these things. Um, so there are, like, you can make your own like mind map or something. So P implies Q can be converted into a disjunctive form. Like, it is, you can represent it in disjunctive form, but you have to change. What you have to change is you have to change the first antecedent, which is P here. P not, becomes not P, and the here the operator changes into O. Okay, so you have to change it like that. Not P or Q. P implies Q to not P or Q. Okay, so in the same manner, if you are to turn a disjunctive form into an implication form, what you are going to do is just change the first options we call in this kind of this kind of form, we call them these items we call options. So because it is, එතන තියෙන වියෝජකයක් නේ තියෙන්නේ. So වියෝජකයක් තිබුණාම එතන තියෙන විකල්ප දෙකක්. So those are options. We can choose, we can pick one. So we call them options, and the first option should be the negation, like negation of that should be there if you are going to convert into a implication. So this is how we convert this implication into this, and also we can change this or gate into this implication as well. That is simply by changing the first variable here. The first variable, if it is a negated one, or maybe if it is not p, it should be p. And if it is p here, if you are going to convert into an implication, you have to, what you have to do, you have to change the negation. Like if there's no negation, you have to add a negation, and if there's a negation, you have to remove the negation. If you are to convert these two, uh, or maybe yeah, turning it into implication, or from implication to an o. Okay, in that is the first thing. Okay, then the second thing, uh, we can take like what are we going to do? Okay, this one, uh, p conjunction q. I think it is visible. Well, 1, 2, 3, 4. The fourth one, from the first, the fourth one. So p connected by the connective conjunction, p conjunction q, is the equivalent of p implies not q, the whole expression's negation. Okay, how that happens? So we here, what we are going to do, I might do it like this. Let's see. So I think all of you can see me. I'm going to show you how it happens. So the first thing I told you, can you see that? I don't know whether you can see it. Is it visible? Is this way possible for you? Is visible? Is this visible?
අපිට ස්ලයිඩ් එක තමයි පේන්නේ you.
Okay.
Yeah, you can see the slide though.
Yeah. Okay.
Yeah,
So
that no, it's okay. Keep going. We can see you now. We can see you. I think I have problem with my network. It says that.
okay, let's do this like ඔගොල්ලෝ මං කියද්දි note එකක් දාගන්න පුළුවන් නේද? කියනකොට. Okay. The first thing, the first rule, if you are going to change an implication into a disjunction, you have to change the first option or the antecedent, which means you have to add a negation or remove the negation. It's alternatively you have to do that. If there's a negation, you have to remove that. If there's no negation, you have to add a negation. Add a negation. Okay, that is the first thing. And oh wait, yes, that's what you're supposed to do. Okay, here. Adding a negation, and I think that is clear. And the next thing, here, this one, p conjunction q should be, if it is going to be an implication, or the other way around. If it is an implication, you are going to turn into a conjunction. What you are going to do? So it is between conjunction and implication. Earlier it was conjunction, not the conjunction. It was implication and the disjunction. Here conjunction and the implication. Okay. If so, what you are going to do, you are going to change the second variable, which means the consequent or maybe the second option. You are going to like the same thing. You are going to ඒක අනිත් පැත්ත ගහලා තියෙන්නේ. ඒ කියන්නේ ඒක නිෂේධනය කරන්න තියෙන්නේ. එහෙම නැත්නම් කරන්න තමයි තියෙන්නේ. Negate that. Negate it and then negate the whole statement as well. Right? You have to negate the first statement, which means after negating the second option, you have to negate the whole statement. Then you get the equivalent of the other statement. ඒක ඔයාලට කරන්න පුළුවන් implication එක තියෙන එක ඔයාලට අවශ්‍ය නම් conjunction එකක් කරන්න හරි conjunction එකක් ඔයාලට implication එක කරන්න පුළුවන් හරි අවශ්‍ය නම් ඒක කරන්න ඕනේ. Okay, so with that we covered the first one and the fourth one in the grid. Okay, and we'll see the same thing happens in the third and the first one. Okay, first one it was the implication and the disjunction, and in the third one also the disjunction and the implication. The only difference is, I think you can got the idea, right? That is the same thing. P disjunction Q equals to, we have to change that, not P, it changes into not P, and other things remain the same, right? That's it. Okay, the first rule I told you. Then the second rule, we did that here in the fourth line. And then we don't have the example here. Okay. So in the same way, in conjunction and implication also, we can interchangeably, we can use that idea. And if it is, now here we don't have that, but I'm going to tell you, what if it we are going to change conjunction into a disjunction? What law do we need? What law do we need? A conjunction into disjunction and disjunction into conjunction. We use what? De Morgan's law. So just simply applying that, we can get an equivalent. So which means we have to change the we have to negate the to both variables and then the whole expression as well. Okay, you got that. I guess you got that because you know De Morgan's law. And then let's see what are the other options, what are the other ways we can make equivalences in conditional statements. So the second here in the grid, P implies Q, which is equal to not Q implies what? Not P. So I told you in the beginning, this is what this is, what is this, what do we call this when this kind of expression is given? If we write it like this, what is this? Hello.
Yeah, we are here.
Huh? So what is the answer for that? What do we call that? That P implies Q turns into not Q implies not P.
That's um,
That should be contrapositive, right?
yes.
Okay. So which means හිතන්න තේ හැදුවොත් තේ බොනවා. Okay. තේ හැදුවොත් තේ බොනවා and තේ බොන්නේ නැහැ කියලා කියන්නේ තේ හදලා නැහැ කියන එකනේ. The same. Did you get that? තේ හැදුවොත් තේ බොනවා. එහෙනම් තේ බොන්නේ නැහැ කියලා කියන්නේ තේ හදලා නැහැ කියන එක. So those are equivalent. So you can check whether it is true, whether what I'm telling you is true by simply drawing a truth table. Okay. Okay. Then what else? We have what is it? Only 15 minutes left. Okay. Then here the latter part, these ones I think you can understand easily. P implies Q, P implies R, so we can get the this connective out. The same thing, you know, in the other, you know, parts as well we did that, so I think it's possible. I think only new thing is here. And the biconditional statements, here we can make similar statements like this. P biconditional Q equals to P implies Q, and Q implies P. Okay, that is what that's you know. Okay, then P biconditional Q, the same we did here, getting the contrapositive here, just by changing, just by negating the two values. And not like that, like we have to do something here. Okay, we know that these two, like no, P implies Q and Q implies P, those two. Okay, so you are going to, what you are going to do is this. You are going to unlike here, like here in the conditional you just change the whole thing, like you are negating the two variables and change them. But here you don't have to change them, because you know, wherever these two are, you know, it doesn't matter. The you know, not P, මෙතන not P තිබුණත් not Q තිබුණත් it doesn't matter, because they are interchangeable. Like the position doesn't matter when it comes to biconditional, because it anytime it has to go both ways, so the position doesn't matter. You got that right?
Yep.
Okay. Then P biconditional Q, we can write, yes, P and Q happens, and not P and not Q happens. What is that? So P and Q happens, which means it is like this. It is simply we are writing down the, you know, some sections in the truth table. You see how like, you know, the expression as it is shown here. ඒ කියන්නේ මෙතන කියන්නේ PQ එකට වෙන්න පුළුවන් සහ PQ එකට නොවේ තියෙන්න පුළුවන් කියන එක. That is exactly what is in the truth table, right? So in what is truth table, what is there in the truth table, we have demonstrated in the using an expression like this. So අනිවාර්යෙන් වෙන්න පුළුවන් options දෙකක් තියෙනවා. ඒ දෙකෙන් එකක් වෙන්න ඕනේ. So that is why we use disjunction in the middle. Okay, here this part. So P conjunction Q can happen also. Not P conjunction Q, not P conjunction not Q are the two options that are possible. Then, and one might ask, why don't we use conjunction here? We don't use that because, you know, in under this, you know, these two are just options. One of these can happen, not the two things happen at the same time. Okay, that is why we don't use a conjunction here. But here we have to obviously use a conjunction because this is biconditional. Okay, you got that, I guess. Okay, then here the last one in biconditional statements, P biconditional Q and the opposite of it, or the negation of it. So what would be the answer? It should be P biconditional not Q. How can that happen? Just draw the truth table and see. Okay, here what is mentioned here is uh, um, then let's take the same example I took a while ago. Te hadwanam te bonama te hadwanam hanam pamanak. If like if it is done and only like if it is and only it is done, this thing happens. So the fact that the statement, the whole statement is false, which means ඒ කියන්නේ මේ හිතන්න තේ හැදුවතින් තේ බොනවා. හරිද? එහෙනම් මෙතන කියන්නේ තේ හැදුවතින් තේ හැදුවනම් විතරයි අපි තේ හැදුවානම් හනම් පමණක් අපි තේ බොනවා. හරිද? ඒක කියන්නේ අපි තේ බිව්වතින් අනිවාර්යෙන් තේ හදලා තියෙනවා. තේ හදලා තියෙනවා නම් අනිවාර්යෙන් තේ බොනවා. Okay. That statement, the whole statement is negated here, which means තේ හැදුවා හදලා තියෙනවා නම් හා තියෙනවා නම් පමණ තේ බොන්නේ නැහැ කියන එක. තේරුණාද? ඒ කියන්නේ මේ කලින් කියපු එක බොරුවක් කිව්ව නිසා මේකේ දෙවෙනිට කියපු එක අපි බොරුවක් කියන එක හරි කියලා දන්නවා. ඒක පැහැදිලි නේද? නැත්නම් ඒක තව ටිකක් පැහැදිලි කරන්න ඕනද? You got that? Or else I can explain it a little bit. Guys, got it. Okay, then no problem. If you have problems in understanding that, you can simply just send me a text. Then constructing neurological sequences, these things you can do based on the knowledge that you gained now. And these are the exercises, and yep. Then we are moving on to the predicate calculus. What is the purpose of having predicate calculus? Actually, this sentential logic, which means these sentential, like all the statements, prepositional statements, are just for statements that are, that has no quantifiable features. ඒ කියන්නේ statements වල මේ ප්‍රමාණී කාරක ගුණයක් නැහැ. ඒ කියන්නේ ඒක කොහොමවත් ඒ කියන්නේ මේ කතා කරන්නේ if it is just about just a one person or maybe all ඒ කියන්නේ මේක අපිට මේක develop වෙලා තියෙන්නේ මේ predicate calculus කියන එක with the advent of set theory. Set theory එක develop වෙද්දි තමයි මේ ඒක ආවේ. එතකොට මේ quantifiers කියන ඒවා අපිට අවශ්‍ය වෙන්නේ to දැන් හිතන්න අපි කියනවා මිනිස් අපි හිතමුකෝ UCSC ශිෂ්‍ය ශිෂ්‍යාවන්. හරිද? So UCSC students, so undergraduates. So in that there are different people, like they're different person. So that when we are talking about just one person, that is special, right? That person is special. But here in this earlier method, we cannot highlight just one person. We cannot highlight a group of people out of the whole people. So all people cannot, like we are referring to the whole people. So which is not really what we want to do. අපිට ඕනේ කතා කරන්න not about the whole people. We are going to talk about the half of it, maybe 10 people out of the UCSC undergraduates, like that. But we cannot highlight that in which calculus? In propositional calculus. That is why we are moving on to predicate calculus. So in predicate calculus, we have quantifiers. So what are predicates first? Predicates are not propositions. Not propositions. Predicates refers to, in English grammar, you know what predicate means. which can be explained in Sinhala as Akyate, which means it represents something is happening, something is doing, something is maybe, yeah, something is happening to, or something maybe like and there are an attribute to that, something like that is there. Okay, so uh, in order to show that, we use uh, predicate. So predicate means simply, if we are attached to something, let's say we are referring to a variable, and that referred variable has this kind of attribute, this kind of quality, we want to talk about that. That is why we use these predicates. Predicates are normally represented in a scheme of abbreviation in like in the form of let's say uh, like there's a standard for that, but here we don't follow that those standards as they are, just using that. So if I make you go through, like, are there any Tamil only speakers? So let's check. No, right? So then I can share you uh, a note that I have in Sinhala. No, no, no. It's better to avoid those things. It's taking too much time. So predicate. I think these things are simple, right? You can understand these things. Is there anyone who cannot understand these things? Just please simply send a like a message if you have any problems with this and in understanding these things. Like, I mean, the sections that we are going through this in this part in predicate calculus. So it's simply like you know these things. Let's take one by one. Normally we start writing, there are several sections. I think it is better to have that note here. Okay. Okay. uh, sort of. Okay. uh, okay, these are the basic stuffs in predicate calculus. So this is what we call these things. We call we had these in propositional calculus as well. We call this sequential. Sorry, not sequential. Sentential connectives. Okay, sentential connectives, and then we have wait. Brackets. Okay, with brackets we like make it more clear. Don't like get confused with all the stuff here. What we are okay. The next thing, the third one, is quantifiers. Those quantifiers are represented in a different different way here, but the first one appear here is all, which means which represents something, for all. For all, it is like this. So to in order to show that, we use this first sign here. Okay, the first one here, this one. And but the standard form that we use is actually something else. Maybe I can send, I think I might send it to the chat. The standard that we are supposed to use, I think all of you know that. So now where is the sign? Okay, anyways, I think you have the note at least. So it's a waste of time. So you have the idea that these are the quantifiers. And then after the quantifiers, then we have these other variables. So these are the variables that are specifically we use for predicate calculus. So these variables actually represent the each and every not the every each element in the set. So it may be in the same set there may be different variables, right? So it is possible. So those are represented in these simple a b like that. And you can use other Latin and Greek letters as well. Then these are name like name letters, which means a b, likewise we it goes on. But actually there's we did not like come across these few, but these things, p to z, those letters, we have done those things in propositional logic. So it is used in here as well, but we didn't see that is being used obviously in the lecture. And uh, here special character f to o we use predicate, especially letters for predicates to identify predicates. Okay, then that's it. Those are the components of this. Okay, I think you got an idea about that. Then moving on to something else. So I think you can represent English expressions in predicate calculus. Anybody having any issues regarding that? I mean, representing something, some expression in a predicate calculus, like using quantifiers. Do you have any thing to like sort of? Or else if you have actually we don't have time to discuss the questions though. I've sent a list of questions, but you can just try them. So with that, what are we going to do now? Um, okay. Consistency part. Um, okay. Quantifiers, universal quantifiers. Okay. Uh, okay. Another important thing that I would like to tell you, why we call universal quantifiers and existential quantifiers. Normally, if we are going to uh, talk like in a more deeper level, universal here implies the fact that it all all the elements here inside that which has the same variable are like taken together. So that is the main purpose of universal quantifier. And if you are going to referring to some attribute uh, in which is there in all that particular variables, we refer to universal quantifier. And the existential means actually there's a theory behind that. Existential means we are talking about something existing, and in but in order to understand that, you have to have an idea about these the basic proposition types. There are proposition types, Aristotelian propositions. So you can, I think it is something out of our scope, so that I'm not going to explain that. So with that, let's have a look at how to see the consistency um, in a system. Okay. Okay, one only two, three things that we are going to talk about now. So one thing is consistency, and the other two things. I think anybody having issues with understanding existential quantifier and the universal quantifier, do you have any idea as to what these existential quantifier mean? Like it is because අපි එතනදී refer කරන්නේ මෙහෙම දෙයක් තියෙනවා කියලා. Like there are some people, some people are like this කියලා අපි කිව්වට, we are talking about existence of some people. Okay. But universal එකේදී අපි කියන්නේ all, හැමෝම ඉන්නවා. හැමෝම ඉන්නවා කියන නෙමෙයි, we have a preconception that everyone ගොඩක් ඉන්නවා කියලා. But some එක පාවිච්චි කරද්දී අපි කියන්නේ, we say there are people like this. So which means we are talking about the existence of those people. So it is something something related to philosophy as well, but no use of talking more about that. Just to understand that, I wanted to add that. And the consistency, where is that part? We missed that part. Consistency and showing the propositions are equivalent. So when showing showing the fact that these propositions are equal, what are we going to do? Anybody having any idea as to what we are going to do? කාට හරි idea එකක් තියෙනවද මොකක්ද කරන්න කියලා? Propositions දෙකක් equal ද නැද්ද කියලා බලන්න. We get the two propositions and then make the truth table. That is the only thing that we have in the syllabus. So that is we are going to do. So then getting the final output and see and check whether those two are equivalent. That's it. That is the thing that you have to do. And when it comes to consistency, where's that part? I think it is somewhere here in under, not before the circuits. Okay, system specifications under that. So system specifications. Okay, consistency. What does consistency mean? ඒ කියන්නේ මම උලදීම කිව්වා maths කියන්නේ logic කියලා කියන්නේ systems ඒවා deductive systems. So deductive system එකකදී ඒකෙදී අපි පාවිච්චි කරන මොකක් හරි දෙයකට පාවිච්චි කරනවා කියලා හිතන්නකෝ truth value එකක් දෙනවා කියලා. ඒකට ඒ දෙන value එක ඒ මේ සම්පූර්ණ system එක ඇතුළේම ඒ variable එක පාවිච්චි කරන හැම තැනකම it should be the same. Okay, so එහෙම එහෙම වෙන්න ඕනේ. ඒතර එහෙම එකක් තමයි consistent කියලා කියන්නේ. එතකොට a list of propositions is consistent if it is possible to assign truth values to the proposition variables so that each proposition is true. එතකොට හැම proposition එකකටම values truth values දැම්මම පස්සේ ඒ propositions වල proposition variables වල හැම value එකකටම හැම proposition එකක්ම true වෙනවා නම් අපි කියනවා ඒක consistent කියලා. ඒ කියන්නේ අපි ගත්තොත් එහෙම if we are taking several මොනවා හරි අපි ගන්නවා හිතමු expressions තුන ගත්තාම expressions තුනේම අපි හිතමුකෝ එක අවස්ථාවකදී කියන්නේ අපි ඒක list down කරාම truth table එක ඒ truth table එකේ එක combination එකක විතරයි. කියන්නේ when p is true and q is false some expression is true. Okay, let's assume so ඒ විදිහටම තවත් expressions දෙකක අර values දෙක එහෙමම තියෙද්දි output එක true වෙනම නම් ඒ විදිහේ අපි ගන්න අපි හිතමුකෝ මොනවාද expressions තුනේම එහෙම වෙනම නම් හරි මම මෙතන example එකෙන්ම අරගෙන කියන්නම්. Let's assume where is that? Okay. Okay. Here, this statement and this statement and this statement, those three, ඒ තුනේම එක අවස්ථාවකදී මේ අපි එකේම අපිට අනිවාර්යයෙන්ම එන්නේ there are four ways that we can get values නේ. ඒතර ඒ හැම අවස්ථාවකම අපි check කරලා බලනවා එක අවස්ථාවකදී කියන්නේ අපිටම TF තියෙන වෙලාවක TF තියෙද්දි මේකේ TF තියෙනවා මේකේ TF තියෙනවා මේකේ TF තියෙනවා කියලා හිතන්නකෝ. ඒතර ඒ හැම අවස්ථාවකම ඒකේ මොනවද output එක එන්නේ true නම් ඒක අපි ගන්නවා මොකද consistent කියලා. Because all true හැම එකම true මොකද මේ p is false and q is true එවන අවස්ථාවකදී. එතකොට එහෙම තමයි ඒක ගන්න ඕනේ. දැන් මෙතන ඒකේ අර මොනවද the diagnostic message is stored in the buffer or it is retransmitted. The diagnostic message is not stored in the buffer. If the diagnostic message is stored in the buffer, then it is retransmitted. So එතකොට එතනදී මොකද වෙලා තියෙන්නේ? The diagnostic message is stored in the buffer and let Q denote the diagnostic message is retransmitted. ඒක අපි දැන් මේ logical expression එක ලියාගත්තට පස්සේ එන්න මෙහෙමනේ. පල්ලෙහා අපි දැන් කියපු එක විදිහටනේ. ඒකට ඒ ආවට පස්සේ අපිට පුළුවන් මේකට බලන්න truth table එකක් ඇඳලා. එතකොට ඒ ඇඳලා පස්සේ ඇඳපු එකේ අන්තිමට එන අවුට්පුට් එක තියෙනවනේ. දැන් මේකෙත් මේකේ එන අවුට්පුට් එක එන්නේ මේ disjunction එකට. මේකේ එන negation එකට අවුට්පුට් එක එන්නේ. මෙතන එන implication එකට. ඒත් මේ ඔක්කොගෙම truth වෙන එක අවස්ථාවක් තියෙනවා. ඒ අවස්ථාව තමා when P is false and Q is true. ඒ වෙන අවස්ථාව තමයි අපි පික් කරගන්නේ මේ consistent වෙන අවස්ථාව කියලා. So අපිට ඒක ඔය පාවිච්චි වෙන අවස්ථාව සර්කිට් වලදී එහෙම මේ අපි පාවිච්චි කරන්න ඔය කතන්දරේ තමයි. ඒක තමයි මේ logically මේ explain කරලා තියෙන මේ ඒ කතන්දරේ. ඊට පස්සේ ඒක system specifications එකේ වෙන දෙයක් නෑ නේ. Yes, that is it. So with that we are going to end the Kuppi. Ravindu?
Yes, thank you, Jude. I hope we'll be able to continue these types of Kuppi classes in the future, like when the exams are coming up. Thank you for conducting this with a quick notice. So, thank you, Jude.
And it's pleasure to be to you all. Thank you for giving me the chance.
Okay, thank you. See you guys in tomorrow.
Okay, bye. Good night.
Bye. Good night, all. So the guys who recorded, contact me tomorrow. Like, if someone recorded, send me or Isum. Is Isum here? Isum, are you here? Isum? Isum is here. It's not speaking. So, how the record करे? Viman? Viman is not here. And Pasendu Rajapaksha. Pasendu recording का हारे दे? Pasendu is not here also. I think. And okay, Kavisha. Kavisha is sleeping, I think. So okay, those who want recordings, send me a message. Okay. Good night, and leave the meeting now. Bye.